In the diagram, AB is equal to x, vector BD is equal to 2x plus 6y, and vector CD is equal to 2y. Expressed in terms of x and y in simplest form, the vector AD. And so here we have AD, but what is AD equal to? Well, so if we notice carefully, we have AD, which means that we start at A. So we start at point A, and then we're going to end at D, all right? So we end at D. Okay, so we're going to go from A to B, right? So A to B, and then we're going to go from B all the way to D, okay? And so now, so that's why that AD is equal to AB. So we go from A to B, and then we go from B to D, from B to D. Now, what is AB, right? Well, AB is equal to X, and so we have X right here. And what is BD equal to? Well, BD is equal to 2x plus 6x. And so BD is equal to 2x plus 6x. Next, we simplify. And so what we have here is we have x plus 2x. What is x plus 2x? Well, x plus 2x is simply 3x. And so we have that AD is equal to 3x plus 6y. Next, we factorize, and so we have that AD is equal to 3 open bracket x plus 2y, and that makes sense because 3 times x is 3x, and we have 3 times 2, which is 6. I'm sorry, we have 3 times x, which is 3x, and we have 3 times 2y, which is 6y. And so AD, right, would be factorized though. So AD is going to be 3 open bracket x plus 2y. And that's the answer to this question. AD is equal to 3 open bracket x plus 2y. Next, we have to figure out what is a BC. What is vector BC equal to? Now, BC, right? So this is BC. And BC is equal to BD, all right? So what does BC even mean? BC means that we start at B, all right? And we end at C, all right? So BC means that we're gonna go from B to D, right? B to D, and then we're gonna go from D to C. We're gonna go from D all the way to C, all right? All right, so let's move forward. So we have BC is equal to BD. What is BD? BD is equal to 2x plus 6y. That's what BD is. BD is equal to 2x plus 6y. And then we have DC. So this is DC. And DC, notice that if we go from C to D, that's negative. I mean, if we go from C to D, that's 2y. But we're going from D to C. So that means that we're going in this direction. And we're going in the opposite direction of CD. And so that means that instead of having 2y, since we're going in the opposite direction, we're gonna have negative 2y, all right? And so, right? And so what do we have, right? We have 2x plus 6y plus negative 2y. All right, next we have positive times a negative, and a positive times a negative is a negative. And so BC is equal to 2x plus 6y minus 2y. Now what is 6y minus 2y? 6y minus 2y is equal to 4y. So BC is equal to 2x plus 4y. And we can factor this. And so that means that BC is equal to 2 open bracket x plus 2y. And that makes sense because 2 times x is 2x and 2 times 2y is 4y. And so that's what BC is equal to. The factored form of our answer is 2 times open bracket x plus 2y. Okay, so now we know what BC is. The next question says, write 2 geometrical properties of AD and BC. And so what are we gonna write? Well, well, I have given 4 properties, all right? But before we go over what's happening here, because it's a lot on the screen, I'm gonna first give our answers to the previous questions, which is gonna be useful in understanding what's happening here. So based on our previous question, the first one, AD is equal to 3 open bracket x plus 2y. That's what AD is. And BC is equal to 2 open bracket x plus 2y. And so this is what AD is, and this is what BC is. And so that's why we say, okay, well, all right, we said that AD, right, that's what we say, AD is equal to 3 open bracket x plus 2y. And that's true because that's what AD is. That's what we have from our previous question. AD is equal to 3 open bracket x plus 2y, all right? Okay, so that's all fine and dandy, that's nice. We know what AD is, right? AD is 3 open bracket x plus 2y. But what's interesting is that AD, right, can be expressed as, there's a different way we could express, this is the same answer, but we could express this answer in a different way. And we try and express it in a different way so that we could be able to see something that we probably will not be able to see if we just leave it as that, right? And so, okay, so we have that AD is equal to 3 open bracket x plus 2y, but this 3 open bracket x plus 2y can be written as 3 over 2 open bracket 2 open bracket x plus 2y close bracket close bracket. Now that makes sense because if we were to take, okay, if we were to cancel out, right? So if we were to cancel out this 2 with this 2, what are we left with? We're simply left with 3 multiplied by x plus 2y. And 3 multiplied by x plus 2y is still AD, all right? And so that's why these two expressions are equal. So 3 open bracket x plus 2y is equal to 3 over 2 open bracket 2 open bracket x plus 2y close bracket close bracket. So these two expressions are equal. And the reason why they're equal is because all we have to do is cancel out the 2 2's, all right? And we are left with the 3 and x plus 2y, and that's exactly what AD is, all right? But by expressing it in this way, we get to see something, right? First of all, we get to see that these two are actually equal. And the second thing that we get to see is we get to see that, hey, well, okay, what is this? What is this inside there? What is this? Oh, this that we have in blue, well, that's exactly what BC is, right? BC is actually equal to 2 open bracket x plus 2y. But what we have here, this is BC. So, okay, well, let's just substitute BC into this equation, into this expression. So we say, okay, well, this is BC, and that's what BC is. And so we're just gonna put BC here. And we're gonna keep 3 over 2. And so that's 3 over 2 multiplied by BC. So what that means is that AD, which is equal to this, and it's equal to that, that means that AD actually is equal to 3 over 2 multiplied by BC. So AD is equal to 3 over 2 multiplied by BC. And so what does that mean? That means that we have this vector, and we can multiply it by this scalar, which is 3 over 2 or 1.5. So we could take this vector and we can multiply it by the scalar, and that gives us the other vector. And so what does that mean? That means that one vector is a scalar multiple of the other vector, which means that these two vectors are parallel, right? That's what it means to be parallel. When you could take one vector multiplied by a scalar and get another vector, that's exactly what it means to be parallel. So since AD is equal to 3 over 2 BC, which basically means that these two vectors are scalar multiples of each other, this means that vectors AD and BC have the following geometrical properties. Number one, the vectors AD and BC are parallel, all right? Number two, the vectors AD and BC are scalar multiples of each other, and that's what it means to be parallel. The vectors AD and BC have the same direction. And we know they have the same direction because 3 over 2 is positive, all right? And then vector AD is 3 over 2 times longer than vector BC, all right? So if I was in the exam, they only asked for 2. If I was in the exam and I wanted to determine which 2 I would use, well, I'll definitely go with this one. This is a good one. The vectors AD and BC are parallel. I would also go with this one, all right? One is longer than the other, all right? And so since they only asked for 2, right? The 2 main ones, if I had to put them in order of priority, I'd say this one is, you put this one first, you put this one second. They only asked for 2, right? But if you cannot remember the second one, then you could put this one third. This one, the fact that they are scalar multiples of each other, I would definitely put I would put that they are parallel instead of saying that they are scalar multiples of each other, even though it's still true, right? But I would definitely put that they are parallel, and I would definitely put that one is longer than the other, all right? I'm still not sure if the fact that they being scalar multiples is actually a geometrical property. I'm not sure of that. But definitely, so that means I would say since AD, this means that that means that AD and BC have the following, let's just say the following properties instead of saying the following geometrical properties. Because I'm not sure if the second one actually counts as a geometrical property. But if we're looking for 2 geometrical properties, I would definitely go with the fact that they are parallel. That's definitely a geometrical property. And the fact that one is longer than the other, that seems to me as a geometrical property as well. And the fact that they have the same direction, that also seems like a geometrical property. So 1, 3, and 2, I would say that they count as geometrical properties. But the second one, I'm not sure. It's a property. It's a result of this, but I don't know if it's a geometrical property. But definitely 1, 2 for sure, and 3. But in order of priority, put 1, 2. And if you can't remember 2, then you could put 3. So you could put 1 and 3 or 1 and 2. All right. And so that brings us to the end of this lesson. Hopefully you understand this, and I'll see you in the next video.